All right, here we go. We are doing, it's the last page of the notes for today, Monday, Halloween week. We're doing practice to become proficient. And it was a question that was asked right before I started. What are we supposed to do with these? That's my gift to you on this page. I wrote the polyatomics there. It was actually a gift to myself also. So I didn't have to keep flipping back and forth and back and forth. But again, I talked about this in lecture. I highly recommend you make your periodic table, put the polyatomics in there, or make a card with them on it and with your little thing about losing an oxygen goes to I, gaining an oxygen goes to per8, about the acids, eights become ix and ites become us. So by you making your own little chart, that will help you to understand it. I mean, you can cut out the ones that I had in the lab too, but when you write it down, it helps it to flow better. And so it will make other things as we're going through it. Now, actually, I think the most important question on here is actually this one, where I said, which of these are molecular? So just looking at the first group, so A through H. The molecular ones are only nonmetals. They're going to be the, there's actually several of them. So A would be molecular. We see a metal, we roll it out, and G. So remember, acids are also molecules. So A and G in the top part, and you can look at the ones below. Also, it looks like L and M. The font is really funny on this page. And also L and M. So that's a really important question because they are named differently. So it's something I actually recommend to students, that you may actually want to first find those and get them out of the way. So these are the ones that get the counting. So silicon tetrachloride. These were the ones on your lab that you were supposed to leave blank spaces in the middle because there's no ions. And we'll also do this one down here is just 2 nitrogens and 4 oxygens. So it's just telling you what there is, N2O4. All right, let's go for the other ones. We'll save the acids. So with the ionic, well, I don't know if anybody noticed my fish necklace. I got that in Nepal. I was like the second day in Nepal, and then the people, my husband and son took the money away from me because I did not negotiate well, and everyone just like wanted me to buy from them, and I would just buy from everyone. All right, just a lot of fun. You want to ask yourself, there's 2 questions. One is, do you need a Roman numeral? And so which ones are going to need Roman numerals? Well, not B or C. D needs a Roman numeral. You're not allowed to talk. She just can't do it. D, E, and F, and H. I'll put a little question mark. I put zinc on here for that reason. Zinc is still one of those ones that's on the cusp that some people, like your teachers, say put a Roman numeral. And some people say don't. I don't really care. All right, so B and C, no Roman numeral. We just write potassium and magnesium. And the second question you want to ask yourself is then about the anion. Is it a polyatomic? So having this nice list there, this one's just F. So the ending is IDE. And Tiffany, I do actually absolutely appreciate your participation always. You have to keep your voice quiet. All right, this next one is a polyatomic. The 2 is outside the parentheses to balance the charge of the magnesium. We're not worrying about charges here because we don't have to do Roman numerals, but chlorate is ClO3. So chlorite would be ClO2 negative. That is not what this is. This is ClO. This is that next one, which is the hypochlorite. You know, and I will honestly tell you, the students did amazing with this for 25 years, and they had to really learn it. And so I would learn it. You guys can have your notes there, but make it so it's simplified it. So you're just saying I minus an oxygen. I mean, you can have that thing where you have 100 different polyatomics, but you're not going to really, I don't know. Are you ever going to fully, are you ever going to have to name again in your life? Maybe not, but it is still a pattern, and it's understanding patterns, right? The chromium gets a Roman numeral, add a parentheses. I am absolutely fine with that. Around the PO4. PO4, it is right there. It is phosphate. Checking your number of oxygens. So the parentheses is where the Roman numeral goes. The phosphate's a -3. There is only one of them. So the chromium's a +3. That subscript 4 is the number of oxygens. The next one, Pb is lead or plumbum. And the S is just S, not a polyatomic, so that IDE ending. Sulfur, look at your periodic table. Sulfur is under oxygen, it's a -2. Take that moment, do this all very calmly, collect. -2, there's 2 -2s, that means we have a -4. So that means the Pb is a +4. So you can always draw it out. You have an S -2 and another S -2. So you have 2 of them. That's why my Pb is a 4, which is 1 before 5, IV. Fe is iron. And again, parentheses you can put around the SO4. SO4, we check number of oxygens. So it is sulfate. Parentheses, nobody's letting the dog in. They're all talking. And so the iron's a +2. All right, next one is acid. You know it ends with the word acid because it has a hydrogen. That's half of it. So parentheses, ClO4. So we go to chlorate. This is the extra oxygen, so it's per, like the cat. So it's perchlorate. You can write it per like a cat, that purrs. And my poor dog. All right, zinc. I am going to put a Roman numeral. Again, it is optional, only I don't think it is. OH is right there. That is hydroxide. And the Roman numeral is going to be at 2. The OH is -1. Questions? I only took like 5-10 minutes. All right. Sodium oxide. So I recommend showing your ions. So in the lab, I had those extra columns, and so I'm going to go through showing my ions. Sodium is Na with a plus. Reminder, always look and see that it is really common to get sodium's charge wrong because we get so comfortable with it that we don't look. So just make yourself look. Do like several of you have done where you put that periodic table in front of you. Get a large one or make a large one. You can get them for a couple bucks, I'm pretty sure, online. Or get a placemat like I have, because then it's laminated and you can write on it. And oxide means just oxygen. So O is -2. And looking at our table. And then we need 2 sodiums and 1 oxygen. So writing the formulas. Everybody always has one way they like better than the other. So some people like writing the names better, and some people like, no, I like doing the formulas. Ions, we show charge after as a superscript, but in the formula, notice the charge is not there. So that is something, it's like one of those pet peeves your teacher has. I don't show the charges in the final. This becomes a subscript. So another really common, I find it very adorable and cherish it, but it is a mistake that these start floating as you get excited and you're like, I'm getting this, that this 2 starts floating up higher and higher. Make sure it doesn't not attached to a helium balloon. All right, barium is BA. It is a +2. It's in the 2nd column. So if there's no Roman numeral, just double check. And then bromate. So my list only gave you chlorate, but if you know chlorate, and if you've done this, you know, and then a lot of people will write it with it, chlorate, bromate, and iodate. The family behaves all the same. So bromate is, parentheses is really helpful. BrO3, make sure the O is capital O. It has -1. So we will need parentheses. So BrO3 on the inside and 2 on the outside. All right, tin is a sin. The Roman numeral 2 tells us it's a +2. Tin and lead can be a 2 or a 4. They can either lose just their P's or their P's and their S's. So you're always going to be told. And I always like to underline that ending "ide" means just P, and P's -3. So I have the 2 and the 3. So I swap. Right, this goes with the gold. Gold is AU. You can say +3 or 3+. Ite means you lose an oxygen. So we go to nitrate. Oops, here it is. And you take an oxygen away. So it's NO2. When you gain or lose an oxygen, the charge does not change. So nitrate was -1, nitrite is -1. Right. And parentheses are really helpful for most students. This one we do end up with the parentheses. So NO2 and 3. Right, we already did the dinitrogen, so we don't have to worry about the charge thing. It's really nice to get those out of the way. All right, acid. They are molecules, but if you think of them as ions, that makes it easier to put them together. Ic means it was 8. And so we find sulfate in that nice table I put there. And you put a parentheses, so you see it's a package. The SO4 goes together. The parentheses are really helpful for a lot of students, so I highly recommend it. Now the final answer is H2. We need 2 hydrogens, and then the SO4. Technically, there are no parentheses in the answer, but if you like parentheses, because that really helps you, I want that you understand it, that you can see it. And so if you see it then as a package like that. All right, and then the last one is bicarb, because I wanted to do one with that. So calcium is a +2. Again, calcium, like sodium, is one a lot of people get the charge wrong. You look at the table, you absolutely see it's a +2. So just make yourself look, take a quick glance, say yes. Yes, it is a +2. Bicarb does not mean 2. It's not like a bicycle. Di is meaning 2. Again, it was a wrong name and it just stuck because it's so common. So bicarbonate is actually hydrogen carbonate. The whole thing is a package and it still has a -1. So carbonate had a -2. If it was carbonic acid, it would have 2 hydrogens. Bicarb, it picked up 1 hydrogen, so the charge just changed by 1. Right, so for every 1 calcium, we need 2 bicarbonates. And we do a happy dance. And that's it. And I'm going to stop unless we have a question for the better of. All right.